talked about abstract classes as being a good thing. What we're trying to do is set out a regime, a set of behaviours that we want our objects to have, and then we can sort of deal with them in the context of those behaviours. The idea is that the account contains a bunch of idealised things which you can do if you want to be a bank, and then having done that, we can then implement these things in the child classes in a way that works for us. And the 4 things that I pulled out, which all banks do, are set out there as bits of English. And what we do is this, which is the thing which takes the 4 things the account must do, and it puts them all into these abstract methods. So the idea is that this thing is now a template. It doesn't have any behaviours at all. We could never make an account because the account doesn't know how to do any of those things. But the idea is that checking account or whatever else works underneath this does provide these behaviours, and therefore we can make instances of that. Does that kind of make sense? This goes to the intent of the class, not the specific behaviours within it. And so you sit down and you figure out within the business process, what does this object need to do? And then once you've done that, you then sit down and go, okie dokie, we'll express these needs as abstract methods. And then what we'll do is we'll make this a parent abstract template class, and the kids, the child classes will contain realizations. What was that mean? Yes, it was. Yeah, okay. The kids will contain realizations of these methods, and then it'll all just work. That'd be great. Try again. So, when you make a class abstract, you can't make an instance of that class because it doesn't have any. Well, it may well be missing behaviours. But what you can do is you can have references to it. So I can refer to an account even though it's a template, which is actually quite sensible. And so it's just a place, the abstract method is just a placeholder. Should we play with this? Let's have a look. Okay. If I put it in there, it'll just keep on falling out. Let's try again, plan B. I'll now take it home. Don't let me take it home, please, because that's always embarrassing. So where was that? Yeah, push you out the way. Go back into Visual Studio. And let's make a new class. Yeah, okay. File, new project, abstract. Okay, there it is. That's going to cause all kinds of trouble. I apologise. It's actually no. Let's not make it call it that. That's a daft name. It's had to put an at in front, otherwise it gets really confused. Make a new solution. Let's call it abstract demo. That's more like it. Demo. Bang. That's much nicer. So, okay, there we are. And I go in here and I steal my abstract class from the slide deck, as you do. So just knock it off of there. Go to this. Put it in here. Now, this is just expressing the fact that our class will have these behaviours. Doesn't say what they will do. No idea how they work. All it knows is that set name takes a string and returns a bool. Set pay in funds takes a decimal and returns a bool, and so on and so on. Can I do this? Can I do that? Is it complaining?
Yeah, kind of.
Kinda. Yeah, green means it's saying you've made it, but you haven't made it refer anywhere. It's perfectly okay to declare this guy, But at the moment there isn't a type of data in the world I can actually use to connect it to, because all the classes we've got are the abstract ones. So if I go in here and I go class current account extends account, now the rules are, if I want to make any current accounts, they have to have a set name, a pay in funds, a withdraw funds, and a get balance. If I right click on this guy and go quick actions, Visual Studio is awesome, and it says, do you want me on your behalf to make this current account class implement all the abstract methods in the parent? We're going to do that, and if we just say yes, something rather magical happens that saves me a lot of typing. So I go preview changes, and that'll do, hit apply. So now what it's done, which is wonderful, is it's effectively gone through. It knows that the account is the parent class, it knows it's got these abstract methods in, and it's saying, okie dokie, I'll go in and fill those in for you, Rob. It doesn't actually write the program for you, which is a bit sad. It makes all these methods throw the exception not implemented, so they'll all blow up if we try and use them. But I now have a current account that contains templates for all the methods that the abstract requires. Does that kind of make sense? Studio is awesome. So now I can make my account reference down here, account A equals new current account, and that will compile just fine. So when I run the program now, nothing will happen. If I try and go A dot pay in funds 100, then bad things will happen at that point, because it'll blow up, because it'll go into pay in funds, which is down here, hit that, throw, and then explode in a shower of sparks. I've run it now, yeah. Diddly-dee, kaboom, come on. There you go. Didn't like it because pay in funds has not been built yet, which is fine. But this is a great way of saving you typing. So, things to bear in mind. I've flagged the methods as abstract. I've not given them a body. I've just said, okay, semicolon. That's just effectively a template, a placeholder. And if I ever want to make a class I'm going to create an instance of, I have to fill in every single one of these guys. Other things about abstract classes, you can put other stuff in. I could have a method called, I don't know, public string get something, which returns hello for no reason. That's perfectly fine. That means that I can now call get something on my account class. So in here I could go a.get something. If I type it right, it'll work. Get something. There you go. That all works. So there's no. What I frequently do is I'll think of all the things that everyone needs to do, and the ones I know exactly how to do them, and I'll make those not abstract. And then I'll think of all the things it needs to do that I can't specify how it's supposed to work, and I'll make those guys abstract. So an abstract class can contain a mix of fully realized members, which could be methods or data, along with abstract methods. As soon as you put one abstract method into a class, it becomes abstract at that point. It can't not be, because there has to be behaviors for all the elements when you make a new instance, and if one of them is missing, you can't make one of those. Does that make sense? The thing I want you to understand is the reason why you use it, along with how you make it work. And so the idea is that we're never going to make one of these guys, because this is a template. But we are going to make this guy. And because he's got implementations of all these abstract methods, then that's fine. Now, of course, just because an object has a get balance method in it doesn't mean to say that that method actually does what is required in that context, but that's why you have testing. So I can make an abstract class I can use it as a template. The abstract method is simply a placeholder, and yeah, the bottom bullet point is very, very important, just because it says it's one of these talk the talk, walk the walk kind of thing. It's you guys watch Friends, I guess. Everyone watches Friends. The one where isn't there one where Joey claims on his CV that he can speak French? It turns out that he can't. So he has Phoebe teaching in French, which is quite amusing. If you think about an abstract class as a bit of a CV for a class, where there's a bunch of effectively things you have to do to be able to actually function as one of these things, then you then fill those in, and if you're serious about it, you write some tests. So I design my template, and I make some tests to prove that those methods in the template actually behave themselves, and then away we go. If you like, you can have abstract classes at several levels. So if you think in terms of our stock item, think got stock item there, electrical item and clothing item. There may be certain things that every electrical item has to come up with, like get eco rating or something. So there may be certain behaviours that every single electrical item in your hierarchy needs to have. So why not put an abstract method in there to force all the children to actually provide that behaviour? Same is true down in clothing. Maybe in clothing you have to have a washing procedure or something that every single object in your class hierarchy has to have. So you put it in there as an abstract behaviour. The children then have to realise that. So there's no reason why you can't have a hierarchy that contains abstract elements. It's a design thing. It's exactly really how you want to do it. So there you go. This is my current account, and you can see here that I've actually put some placeholder methods in of my own that always work and always return true. This is kind of useful for testing, because what you might do, sit down in the room, design the parent template class, and then farm that behaviour generation out to people who are going to go off and make a few objects each and then come back and plug them in. In the meantime, you might want to have something which actually works on the objects. So these guys are basically placeholders, so I can make current accounts even though they don't do much. There's a technique called mocking, which is where you effectively make fake versions of the business objects, which you can then mess around with and develop other parts of the system with. That's kind of where we're going here. So the idea is that I will fill all these things in, hit the template, and away we go. I quite like this kind of thing. This is Robert's first pass at test-driven development, although there's much better frameworks than the thing I'm building by hand. Make an account with no money in it, give it 10 quid, see if the balance is 10. If it isn't, then you increase the error count and go on. There's actually a mechanism called assert, which you can use in programs that you're testing to say, I assert that the balance will be 10. And if it isn't, then that can feed into a testing framework that will then make a big red light flash at the end to indicate that your tests are being failed. So you would tend to run the development process in terms of, I'll make the templates, I'll decide what each method should do, I'll then build some standard tests for that, and then away we go from there. That's like a nice formal way to write code, and you'll be talking more about that as we go through the course. That's all good, solid stuff. Like I said, it doesn't matter if the parent object has got some behaviours that aren't abstract. That's fine. It's a good way of sharing code and makes really good sense. So we'll make sure that some things are built once at the top forever, and other things we put out as requirements for the children to do. When you're using your accounts or whatever they are, you have a reference to the abstract parent, and that can then refer to any of the children, because it's basically a standard class hierarchy from then on in. So the idea is that if we make a super teen saver account going forward for teenagers, following on from the success of the baby account, then that's fine. It'll just appear in the hierarchy in the appropriate place. It'll implement the methods it needs to deliver as a bank account, and our system can just use it. And this is one of the nice things about OO and hierarchies, is that you don't have to think as a program as being a thing you build once and you can't ever change it afterwards. Because what you can do in this situation is you can build new classes and plug them in later on, and you don't have to change the behaviour of the rest of the system. The class can look after itself. This is very good. It's a way of staying sane. Like I was saying, I think it was last week or week before, a lot of the problems with programming beyond the point where you know what a loop does are ones of organisation. And this is the kind of tool you will use to help you organise your stuff. In terms of a design approach that Robert would suggest, yep, here we go. Step back from the problem. Do not start with dress, start with stock item. As soon as you've got that, you then go through the business behaviours that you're helping to automate, and you find all the fundamental operations and things that they work on. The ones that everyone must do in the same way, they're not abstract, they're just provided by the parent class. So things like get the price perhaps, or get the barcode or whatnot, or get image of product or something, they might always be there. The ones that have to be customized for each class down the hierarchy, they're the abstract guys. They're the ones that you want to basically flag up a need for, but you'll deliver that in a way that makes sense for your particular thing. Things like edit. You could do really funky things like call the edit behavior and pass it a reference to a WPF control and say populate that control with your edit behavior please. IT-ho, and off it goes and does it. That's kind of like a neat thing to do. The idea is that if we do that, we force the children to provide their own behavior for each of these things. That's kind of what we're doing. We're building templates at this point. So, in its raw definition term, abstract means I can consider the fundamental behaviors without worrying about detail. You human beings use abstraction an awful lot. And we'll actually talk about things, we'll talk about a person, and that doesn't, we have very little information about what that person is, or where they're from, or what shoe size they've got, or what colour hair they've got. But if I say person, everyone's got a pretty good idea of what I'm going to mention next. Person goes into a pub, right, we know what's just happened. So we abstract a lot when we talk about things, and we're very good at dealing with abstraction, which is kind of nice. If you're talking to a customer, it's nice if you can talk about orders without having to talk about supplier orders, customer orders, recurrent orders, outstanding orders, or whatnot. So if you can talk about orders in a general sense and find out what you do with them, and then drill down to these different kinds. Same with accounts. What do you do with your accounts? We pay money, we withdraw funds, we change the address of the account, blah, 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 blah. Okay, but these behaviours are different for the different things. So it lets you kind of generalise, step back without worrying about the details. And once you've actually got to the point where you have to provide specific versions of these things, you can do that. And because you can think about using inheritance, you can do that on the basis of the behaviour of parents you might want to reuse. So it's great for that. We work in terms of templates, and the template is exactly that. We can't make an account class because it contains abstract methods, but we can make current account, which extends that and provides realizations of every abstract thing in there. So that's all fine. And so the idea is that what you will do is you'll make a bunch of abstract elements. You will then make a bunch of tests so that they can claim to do it, and you can test that they really can do it. And at that point, you're kind of in business. So it's a way of thinking about design. And it works in every context. As I was mentioning, sprites. Sprites are a fantastic example of abstraction in action. That's poetry. Because they work really well. But bank accounts, the elements on a Windows screen, there's tons and tons of situations where you would like to be able to specify that a thing can do something, but not have to pin it down as to exactly what that operation means when you do it. Does that make sense? Okay. How are we doing for time? Oh, splendid, that's good. So, having done that, now we're all okay. Let's try and blow the doors off and go and have a look at the next level up, which is, I'm not sure how far we'll get with this, but I'll restart it again after Easter if I need to, because this is where it gets really awesome. Is everybody okay with what an abstract class is? Is everybody okay with what a class hierarchy is? Which is the dumbest thing in the class hierarchy? One at the top. So the dumbest thing is at the top, and the smartest, most specific items are way down here, right at the bottom. The lower you get, the more behaviours you get, the more stuff you can do, the more specific you are. Okay? Fine. We've got that. Let's go. Let's break that. So here we go. This is inheritance, and we like it. Baby account is a child of account. Deposit account is a child of account. And this guy here is some kind of abstraction of what an account is. And we love that, don't we? We like that. That's good. Because I can reuse the account behaviours down here and just change the bits that I need to. So, yeah, love it. This is the parent. It's an abstraction of everything else. And we'll never ever make one of these guys because it doesn't do anything. It's a placeholder. It's a template. It's a template that defines accountness, whatever that is. It defines what goes on in this tree down here and what the things in that tree can do. And these guys are the children, and we will make baby accounts and we will make deposit accounts. And they map onto a particular kind of account scenario that our customer wants us to build. And the same will be true if this was sprite and that was player and that was chasing sprite and this one here was, I don't know, silent sprite. And they've all got different behaviours that suit their particular manifestation of spriteness. So you can do this everywhere. Okay, it's a great way to have fun. When I come to build my bank, as I will, then I have an array of bank accounts. Say 100. This is kind of old school. I'd use a dictionary or a list these days, but there you go. And I can have element 0 contains a reference to a deposit account for Rob, and element 1 contains a reference to a baby account for David. How cute. Okay? And we're all alright with this because it all makes sense. Everyone happy? Okay, no one confused? This is basically a recap, but showing you how it will really work. So I have an array of the parent type, and I can put anything in here that lives in that tree. So I could put customer accounts, baby accounts, current accounts. I could put a car in there, could I? Could I put a car in the bank? No, because the car isn't the bank account, so it can't go in. It can't go in there. So if I have a thing called car, can't put one of those in because it's only accounts. Fair comment? Yeah, hold that thought. If I fix a bug in here, it's fixed for all the kids. So if I find a bug in the thing that works out the price or prints out the stock number or whatever it is that happens up here, or the customer comes back and says, account holders must have a name at least 3 characters long. Right, fine. Put it in there. Bang, all these guys get it. Does that make sense? So I can just whack stuff in here, and because the children pick up all the behaviours of the parent, then they'll get it. I fix it once, it's mended for all my account business objects. Love it to death. I fix a bug in baby account because we're not counting other than the nappy count has gone wrong, so I have no idea. Then that won't affect the behaviour of any of my other objects. They will just keep on going exactly as they were before. So I can farm these things out. This guy is sort of atomic in that what happens inside there is the business of the baby account and nothing else. And if we get the teen account coming down the tracks because marketing have another idea, then we can slap a teen account class, which is a child of the account class, fill in the bits and pieces, and it can exist in my list of accounts along with everything else. I can do that on an ongoing basis. In my video game, I can think of new sprite behaviours and I can add those alongside existing ones, and my list of sprites in the game will just be that, a list of sprites. And which particular kind of sprite it is depends on what I fancy putting in there. So this is kind of like I could almost put this to music and sing it as a hymn to the praise of abstract classes and whatnot. Now, here's the thing. Accounts, we're all happy with that, and it's basically an idealised account design. We have deposit accounts and whatnot. Turns out that the bank has a similar kind of mindset for transactions, in that we talked about accounts. These guys contain lists of transactions. Does that make sense? So I keep track of when the money's been paid in or withdrawn or whatever they've done. Okay, so transactions, the generalised, abstract type thing. Then beneath that, I've got payments, I've got deposit, I might have balance inquiry, I might have loan request, I might have, I don't know, there's lots of other things that you go, when you go to the cash till and that menu comes up, every single one of those things on the menu will be one of these, okay? Send me a checkbook. What's a checkbook? I have no idea. Give me a mortgage, blah, blah, blah. These are all transactions, okay? So we've got a separate class hierarchy. It would be stupid to extend one of these guys and put transaction underneath, wouldn't it? From that routine I did this morning, these guys are accounts and nothing else. It's a bit like Romeo and Juliet, really, isn't it? So we've got the Montagues and the Cap, whatever, they sort of can't meet, can't merge because they're different trees. That's probably a bit over romantic, I digress. But you can see where I'm going with this. They're both exactly the same. Then the bank goes off and buys a really expensive line printer, a bit like this one. And the bank says, "You print things out, Rob. We bought this many years ago. I bought a really expensive line printer for the department, and we bought it from Hungary because Hungarian line printers were cheaper than American ones by an awful lot. So I bought this Hungarian line printer, and Robert, not being stupid, said, just in case this thing is broken and we have to repair it, can you please send along a full set of workshop manuals with this printer so we can mend it if it ever goes wrong? And so they sent us a whole set of manuals as well, and of course the manuals were all in Hungarian, which was the bit I didn't specify. So I should have gone for a bunch of English manuals, please, but never mind. Clever people, the Hungarians. I digress. This thing's supposed to print stuff. Fantastic. We want to print out accounts and transactions and personnel records and letters and Lord knows what, okay? Now, there's lots of stuff we want to print. They're all in different class hierarchies. Accounts we know about, transactions, personal records, letters, all kinds of stuff. We want to print all of these, but we don't want to have a list of accounts to print, a list of transactions to print, a list of personal records to print, because what will happen is that after a few months, they'll come up with another kind of data that needs printing, and then I'll have to make a new list and generally mess around. We don't want the print software to have to manage separate lists of items, and yet, because of the fact we've got these rigid class hierarchies, that's exactly what we've got. Is problem? You see what I'm talking about? The printer wants to think about things in terms of their ability to be printed, whereas we want to think in terms of things like it's an account because it's got all those things, or it's a transaction, or it's a record, or it's in that place in the hierarchy. So, what we do is this, and this is close to magic. Okay, I love this. It's brilliant. New C# keyword interface. Give it a name. iPrint. There's a convention in C# that every interface definition, the name of the interface starts with the letter I. And they were doing this before iPod, so we got there first, guys. It doesn't have to be lowercase, although I think it looks cuter if it is. But iPrint, okay? iPrint contains two method definitions, which are the two methods that my printer needs to know. It needs to know what you want to print, and it would like to know beforehand how many lines it's going to use, because the printer tries to optimize its use of paper and generally fiddle around. And so there are two things my printer needs to know to print stuff. It says, can I have the string you want to print, please? And please can you tell me how many lines you need to print so I can get the right kind of paper installed and all that kind of good stuff. Does this make sense? So those are the two things that I need to know. the important point about this is that if I've got an object that can tell me these two things, I don't care what it is. I just don't care whether it's an account, a transaction, a customer record, whatever. As long as it can do these two guys, it doesn't matter. Okay, and that's where interfaces get really powerful. Because what I do is I take my abstract, my account class, I say, okay, you implement the iPrint interface. And what that means is that somewhere in a class that is an account, we have a getPrintOutput method and a getLineLength method. So if you're in a hierarchy and you've got abstract methods in you, then you can be used as a template, correct? And the children underneath provide the behaviors in the template as well. And so I can be a proper account because I've got get balance, set balance, and blah, 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 blah. This is different in that it means that if you implement the interface, I can treat you in terms of your iPrintness and nothing else. So my printer has a list of objects which implement the iPrint interface. So I have a reference to objects that can print, but I don't care what they are. Does that make sense? Abstract classes let me think in terms of family trees. If you're in the family tree, you could do the blah. What interfaces let me think of is things in terms of what they can do, not what they are. So there you go. This is me implementing the print behaviors for the baby account, and I just get hold of the string from the parent class and whack the baby account information on the end of it. So now my baby account can print, and I work my way through all these things. I'm doing this by using a little bit of class hierarchy magic. I override the method in the parent. I then call the method in the parent to get his string stuff. And then I put my string stuff on the end, which is what's happening along here. Repeat the process for the line length, and then away we go. We've done that. That's just an implementation trick. The thing that I'm most keen on is the fact that I can now do this. This is the bit that makes it interesting. I've got a reference of type iPrint called printThing, and this refers to anything which can print. It doesn't matter what it is. Okay, so this allows me, if you think in terms of my class hierarchies going down, my interface can cut across and link all those together. So I'm now thinking in terms of things, not in terms of what they are or where they're from, but what they can do. And we're almost back to Joey and his CV in Friends again, because Joey's CV said, you know, I can speak French, among other things. So if we're looking for a French speaker, that's it. We can use Joey for that. We can use anybody that's got I can speak French. If there's a robot that can speak French, we could use that. So we don't really care what it is. We just care that it has the behavior that we want to use to do that particular job. Now, this is a really, really powerful programming trick, because it means that rather than having to worry exactly what kind of type I'm dealing with, I can just think of a thing in terms of, well, can it do what I want? If the answer is yes, I'll have that. If the answer is no, well, that's fine. It must be something else that I need. So I can have a list of things in terms of what they can do, not what they are. Now, does that kind of make sense? Can you see a need for both? I love my hierarchies because I get all this reusability and fixing bugs and nice design. But I love my interfaces because then I can say, okay, all you guys can save yourselves to disk, can't you? And they'll go, yes. And I go, right, so if I give you a stream, you can save yourself. Yes, I can. Right, fine. I don't care what you are. So all the stuff that has to save itself, I go an iSave interface that has a method called save and a method called load, perhaps, or whatever to call it. It's a bit trickier on load because things have to get static around the place. It's a bit scary, but you can see the principle. If I'm wanting to think in terms of what a thing can do, not what it is, Interfaces are really powerful, and printing is a fantastic example because you know that everything's going to want to print, and you'll want a spool queue, and the spool queue won't want to care whether it's an account or a customer record. And if a new account type comes along, fine, build it, put the methods in that it knows how to do, make it implement the interface, and it plugs straight in. I could talk about things in terms of what they can do, not what they are. The class hierarchy thing is neat, and I'll go through this next time as well, because it means I can pick up behaviours from parents and use those. But that's a kind of digression cleverness. This is the kind of thing which we're really interested in. So the first element in my list of transactions is a my list of print items is a pay-in transaction, and my second thing is a baby account. But because the printer only ever looks at them in terms of can you print or not, it works fine. So this kind of blows the doors off any of our restrictions. Some languages like C#, like C++, they looked at this problem of wanting to combine behaviors in classes and said, right, you can have a thing called multiple inheritance. So I can have a class that inherits from two different parents and bring things together. That's nuts and amazingly dangerous, and C# does not do it because C# has interfaces. Java is the same, Java has them too. In fact, Java kind of invented them and then C# stole them. So in Java you can express interfaces, and the other thing about interfaces which I should mention is very important, a class can implement as many interfaces as you like. So it can print itself, it can save itself, it can sing itself, I don't really care. And each of the things that wants to consume those behaviors can just find an object which actually implements the interface, plug it in, and away you go. Any iPrint interface can refer to any object which can print. So if I try and refer to print thing, which is a baby account, now the weird thing here is that mechanically it will work because baby account has got a pay in funds method, correct? So in theory we can pay funds into baby account, but because we're viewing it through the prism or through the viewpoint of an iPrint interface, we can't do that because you can't pay money in to a printer. So even though the object has got this ability, the view we have of it via the interface stops us from doing that particular thing with it. Bottom bullet point is interesting. I could do casting to get round this restriction, but that's very naughty. So I could, if Robert implements a spool queue for the friendly bank, that means when you print Robert's bank statement, he gives him 50 quid. You could do that, but that would be a little bit of a wayward behaviour that might be frowned upon. And if you're tracking transactions, it will get spotted fairly quickly. So not really a plan unless you like prison food, in which case you never know. So the problem we've solved is that we've now got we've removed the restrictions of the class hierarchy and made it possible to work in terms of something which is much more flexible, because we don't have to adhere to any particular. I mean, JavaScript and Python go one further. Have you heard of duck typing? Duck typing, it's if it walks like a duck and it quacks like a duck, it's a duck. So what Java and Python let you do is you basically lob it an object which it expects to have these behaviors. If it's got those behaviors, wow, I'll use it. So they don't bother with the interface to enforce the thing. They just say, okay, if I'm the printer and you've given me an object, I'm going to try and call the doPrint method on that, and it'll either work or it won't. If it doesn't work, I'll blow up. If it does work, then actually in JavaScript, if it doesn't work, I'll keep going. Because I'm like that. I'm crazy. But in JavaScript and Python, you just lob it the object and it tries to use it. And if it doesn't work, then that's fine, or not. But they don't need the interfaces to enforce it. You can make that kind of system work as long as you never make a mistake, which of course is fine by me, but everybody else might have troubles. The idea here is I'm thinking in terms of objects as their abilities. This is the only piece of clip art you'll find in my entire year, I think, pretty much. a good way to view interfaces is in terms of the design of a socket and a plug. I can go to, that's the point, it shouldn't be on, should it? Which is on, dangerous. I can define this in terms of a series of methods which the client can call. And the client can then actually consume any object that produces the interface behavior by the methods it exposes. And it's pretty similar to how mains sockets work. We have no idea what's producing the mains that comes out of these holes. Could be atomic power, could be an enormous battery, could be a guy on a bike, I have no idea. It's 240 volts AC, fine, that's what I wanted. In the same way, this guy has no idea what's consuming it. It could be a time machine, it could be a laptop PC, it could be a space heater, it could be a kettle. We don't know. So the idea here is that we have this way in which, using interfaces, we can expose a connection which the other side can use. And I use this in sprites because the problem I have in games with sprites is that if you've got a class hierarchy and they have a bouncing sprite here and a bounded sprite here, so the bouncing sprite will do one thing and the bounding one does something else, and you want to combine those behaviors, it's really hard because they're in different parts of the tree. So what I do is I have a component which does one little behavior, like lets the player steer the ship around the screen, and another component which stops that from going off the edge, say. I then have a list of these components inside the sprite, which I assemble to tell the game how the sprite should behave, and it works to the list. So there's the first one, it moves the player with the joystick, and there's a second one, keeps him on the screen, and so on and so forth. So I can make my program up out of components that I plug together. And the fundamental process by which you can do that is because you can design what the socket looks like and what the plug needs to do to use it. And once you've done that, you could put that behavior on any object in your system and turn it into a component. And that's kind of magical. I really, really like this. I thought I'd do it now because I'll probably do it again in slow motion. If this seems a bit hard to understand, then don't beat yourself up on this one, because this is the toughest part of the course, I think. The way to keep your head clear and understand what we're on about is to think in terms of the problems we're trying to solve. We want to reuse code. We want to write something once and once only. We want to make sure that we can add new things and just add the specific extra behaviors that they need to make the whole thing work. We want to make sure that the objects are autonomous in that they don't rely on anybody else to do their thing. And we want to make sure that we can manipulate those objects in a manner appropriate to not just what they are, but what they can do. And if you keep those things in mind and keep looking at these slides and think about printing goes across, because it's an interface type of thing, but paying in funds lives inside the bank account tree because there's no point in having an invoice that can do that. That would be silly. Then you'll be absolutely fine. The key to understanding this really is to keep mapping it back to the context of the problems that you know about and how to solve them. Does that kind of make sense? Any questions on that? It's deep stuff for a Tuesday night.